Hi, I'm Steve Sharp. I'm a mentor in EIR at UC Riverside. I've got with me today Aditya Pandya, who is the technical lead for the portable perfusion monitor technology. Thanks for joining today, Aditya.
Yeah, thank you for the introduction.
A few questions. Hey, how did the idea arise initially for the PPM?
So our group has been working on a project called Window to the Brain since the past 5 years, and it was just creating a window that looks to the brain. So the technologies that we use for it, one of them was laser spectral imaging. So we understood that can look at blood flow properly. So that led to the project for portable perfusion monitor.
So this problem that you've surfaced that the PPM focused on, how did you find out about it? How did you characterize it? And kind of if you could share with what the problem is.
Right. So our team conducted a national eye core interview a couple of years back, and they talked to more than 100 surgeons to understand the problem. And I myself conducted a local eye core program recently last year, locally here, to understand the problem a bit further. So from this, it led to the idea that there is a problem in the plastic surgery domain where when you do a flap surgery, the flap has to be grafted onto like taken from the patient and grafted to another site in the body and has to be revascularized. So once this happens, you have to monitor continuously after the surgery. And at the moment, the technology or the techniques that people use are very subjective. They use pressing it and changing the color and all the subjective methods. So this led to an understanding that we can use a technology such as a portable perfusion monitor to continuously evaluate the blood flow after the surgery, and that can give us an early indication if something is wrong.
Your team has done over 100 interviews, but so you have a pretty good understanding of it at this point. But how does PPM uniquely solve this problem? What is it particular that it does better than other methods?
Yeah, so PPM, what it does is it looks at the site, it looks at the blood flow, compares it to the baseline, as well as gives you a quantifiable value saying that the blood flow has dropped after a certain number, and that means it can give you early warnings and early indications to the care provider to see if the intervention is needed.
And in these 3 to 10% of the times when these methods fail, who pays for it?
So usually the payment depend on the surgery. It happens that the insurance covers it, and some of the surgeries insurance might not cover it. So the payment has to be done by the hospital sometimes.
Wow, that's expensive. And is this patented?
Yes, we have a provisional patent on the technology.
Okay. And what's next for PPM?
So we've done a lot of lab testing on phantoms. Now we want to move to animal and human testing. And once this happens, we want to establish a startup to commercialize the technology.
Terrific. Well, thank you for joining me today for that explanation.
Yeah, thank you.